Wow. Uh, Good morning, afternoon, evening, or anytime you may find yourself. This is Mr. Tanko Blasius. Today we are going to look at ways at which we can help students get a good mark or a good grade in the GC ordinary level physics. Today we are going to take a particular paper, June 2002, paper 2. In this paper, we are going to look at the questions, dive deep into their intricacies, look at the ways in which various questions may be asked, and we looked at how good solutions and good approaches may be given. For that reason, we are going to go straight away to the questions because the questions are as important as every other thing. We don't have much time. This is Tanko Blasius presenting for Home Tutor, and I hope you will find this one very useful. Question 1. What is a force? Name two forces. 1. A. What is a force? Then the second part of the A is name two types of force and for each describe where it acts. You see, when you are describing a force, there are some essential things that you have to know. In defining anything in physics, you have to give the definition and you give its units. For example, a force is either a push or a pull that can either accelerate an object, decelerate it, or stop it completely from moving, or even change its shape. For example, if you take your hands and you hold a paper together, you twist it, a force has acted on it. It has changed the shape of that paper from being a plain sheet to a twisted sheet. And now the force is measured in newtons. So, in summary, a force is simply a push or a pull that can accelerate an object, change its shape. It is measured in newtons. Simple. Accelerate an object. There are many things involved here because the acceleration can either be centripetal, a retardation, or an acceleration that causes an object to move forward or move it at a greater speed than the speed with which it began. So that's why when defining a force, you have to say a push or a pull that is capable of accelerating a body or changing its shape. Then the second part of the question. Name two types of forces and for each describe a situation where it acts. With this, you know that there are many types of forces. 1. You have forces like the upthrust. Upthrust, these are forces that act in fluids and gives the body the buoyancy. What do we mean by buoyancy? The buoyancy is the ability to float. Gives the body that buoyancy. It pushes the body upwards. That's the upthrust. For example, if you are pushing your hand in water, there's an upthrust force which pushes it up and it goes back. Take a container, like a Tangy bottle. Try to push it in water, upthrust will push it back. Then, you equally have a force like the force of gravity. Force of gravity. How does it act? It acts on bodies, pulls down the body towards the earth, pulls down the bodies towards one another. Then we also have electrostatic force. What is electrostatic force? This is the force which pulls charges together, right? That you discover that a body will be capable of bringing a charge with two charges, maybe positive and negative, will come together, will be attracting to each other, while a positive and a positive will repel each other. This brings us to the laws of electrostatics, which we will see in our subsequent lessons. You'll discover that for a body to have an electrostatic force, the true test the electrostatic force is either an attraction or a repulsion, because like charges, from the laws of electrostatics, like charges repel while unlike charges attract. And as we'll be looking forward, we'll see that the only true test for charge is repulsion. That said and done, we equally have other forces, like the force of friction, which acts between two bodies. For example, if you have your hands and you are rubbing them together, you feel that they are getting warm. Why are they getting warm? Because there is friction between the two surfaces. It's the force which acts between two surfaces that are moving against each other. That's the force of friction. Then you equally have other forces like the magnetic force. The magnetic force. These are forces which act between magnets. A magnet will either attract or repel another one, but it will attract or repel a neutral object like a nail, like some tins, some cans. It will attract them. But now this will not be the same when you bring a magnet towards another one, because like poles will do what? They will repel, while unlike poles will attract. The North Pole will repel the North Pole, while the South Pole will repel the South Pole. The North Pole will attract the South Pole. That is how this works. I hope at this point we have seen some few forces and how they work. So at this point, we'll discover that each point, you discover that you have 4 marks there, meaning that when you name each force, you give the way it acts, you describe how it acts, is 1 mark. When you name a force, is 1 mark. You describe how it acts, is another mark. So naming the two forces, any force is 1 mark. Then now, when you begin now to say how each of them acts, is 1 mark. So you end up having your 4 marks. I hope this goes a long way to explain many questions that may be asked in synergy with questions concerning force. Because in this case, we cannot keep on saying that this is that, without really looking at it. Let's look at the way. Yeah, we can see some answers here. A force is a push or a pull that can accelerate a body, change its shape or direction. It is measured in newtons. That's the first part. Then the second part, up thrust. It acts on falling objects and on objects dipped in water. Yes. Then magnetic force acts between magnets and the magnetic materials. Gravitational force acts on objects and pulls the object towards each other. That pulls the body and pulls them towards the body. For example, as you jump up from the ground, the earth pulls you towards it. That is a gravitational force. Then electrostatic force, it acts between charges. Centripetal force, it acts on bodies moving in a circle, pulling the bodies towards the center and making them move in a circular path. Good. A trolley of mass 2 kilograms moved down an inclined plane at 20 degrees to the horizontal with uniform velocity. Explain how Newton's first law applies to the motion of this trolley. You'll see that Newton's first law, we term it as the law of inertia. What is inertia? Inertia is the reluctance of a body to start moving or to stop moving once it starts moving. So, when you are asked to explain how Newton's first law of motion applies to this trolley, it means that as this trolley has been inclined, the plane has been inclined at an angle of 20 degrees, it means that the trolley will keep on moving at a constant speed such that it will not retard or accelerate. This angle with which it has been inclined is to do what? To compensate for friction, upthrust, and so on, so that the body will keep on moving at a constant speed throughout its motion. But unfortunately, Newton's law of inertia does not always apply the way we can visualize it directly, because there's always air resistance that you cannot see. You and I, can we see air resistance? No. So that's the difficulty. But now, know that Newton's law of inertia, that's Newton's first law of motion, states that a body, that is the law of inertia, which states that a body will continue its uniform motion unless a force is applied to it. Okay, if I place a pen on the table like this, somebody will say that the pen is not performing uniform motion. But I bet you this pen is performing uniform motion because it is not moving from place to place. It is stationary. It stays at the same spot. It has zero speed and it has zero acceleration. Therefore, it is in a uniform motion because its velocity is zero. Draw a diagram showing all the forces acting on the trolley. You take your time. What you do is that you draw your trolley. You first of all draw your inclined plane. This is our inclined plane. Inclined at an angle of 20 degrees. Then this is our trolley that we are drawing here. This is our trolley we are drawing. This is our trolley we are drawing. Now, we have drawn our trolley. How is our trolley moving? This one is the traction force. This is the traction force, meaning that the force which is pushing it forward. Then here we have our resistive forces. What are these resistive forces? These resistive forces, you say that resistive forces will include, they will include friction and a resistance. These are resistive forces, friction and a resistance. Now, you will discover that there is what we call here a weight. This one is weight. Right? Then, here we have what we call the reaction force. R. This R is the reaction force, which makes sure that everything here is balanced. You discover that the traction force should be equal to the resistive forces. And now, if we look at it carefully, we can resolve these forces to get other things. For example, looking at it carefully, remember that we have, this is a right angle type of thing. And when drawing forces, you discover this one is moving horizontal to the plane, while the weight is moving downward. Meaning that this force here will be given by what? The weight is given by what? mg. Mass times acceleration due to gravity. And since it has the mass times acceleration due to gravity, we will now have that this force here, because this is opposite over hypotenuse, you will now say that weight over traction force opposite over what? Hypotenuse will be the same as what? Sine will be the opposite over hypotenuse is what? Sine 20 degrees. Meaning that we can say that our traction force will be equal to weight divided by sine 20 degrees. This is force rather. Attraction force will be equal to attraction force will be weight over sine 20 degrees all to the power minus 1. Why are we putting all to the power minus 1? Because when this traction force comes here and this one comes here, you discover that this sine 20 will come here while the traction force will come up here. This will not be minus 1 again. This will rather be sine 20, traction force comes over here, and then sine 20 comes below here. So our weight is the same as what? Our traction force is the same as weight over sine 20. And now, what is our weight? Weight is equal to mg, isn't it? So, since our weight is equal to mg, then we will now be able to calculate other fractions of this force. We can calculate them. But now, let's look at the second part of the question. Name two of the forces whose resultant is 0. Further, we know that the reaction, that's the reaction on the slope, and the weight of the trolley equals to 0, because the reaction should always be equal to the weight of the trolley. Then the resistance forces and the traction force should be equal to 0, meaning that the force that is pushing the trolley down the slope should be equal to the resistive forces that is resisting the trolley, so that it should move at a uniform speed. That's what it is. A uniform meter rule weighs 0.90, is supported by a knife edge placed on the 40 centimeter mark. It is found that the meter rule balances horizontally when a mass of weight 0.45 Newton is hung from the 15 centimeter mark. 1. Draw a diagram of the meter rule balance of a knife edge showing all the forces acting and the position at which they act on the meter rule. Draw a meter rule. This is our meter rule. Now we have a knife edge placed at the 40 centimeter mark. We are going to estimate, we are not drawing to scale. This is our 40 centimeter mark. This is our knife edge. Then now, we are equally told that the meter rule weighs 0.90 newtons. The weight will be at the middle. The weight of this meter rule will be at the middle. This middle is at the 50 centimeter from this end. at the 50 centimeter from each end. Then this one will be what? Our 0.90 newtons. Good. Then we are told that when a mass of 0.45 is hung at the 15 centimeter mark, therefore there's a mass of 0.45 hung at the 15 centimeter mark. You now put here. From here to this point is 15 centimeters, and this mass is walking down, and the force is 0.45 newtons. Then now there's what we call the reaction force, R, on the meter rule, and this reaction force R is 0.45 plus 9.0 newtons. When we add all of this, we have 0.90, rather 0.90 newtons. And what will this give us? This one will give us 1.35 newtons, which is the reaction force. With that now, drawing this one like this gives you 2 marks. Okay. Question number 2. State 2 conditions that must be fulfilled for the meter rule to be balanced and remain stationary. 2 conditions. The moments about any point on the ruler should be equal to 0, meaning that the clockwise moment should equal to the anti-clockwise moment. Let's go to the moments about this point of every force about this point should be equal to 0, meaning that these times the force acting here at this point, let's call this point A, call this one B, and call this one C. The moment of this point are about the point A, of all the forces around about the point A, should be equal to 0. The moment of all the forces about the point C should be equal to 0, and the moment of all the forces about the point B should be equal to 0. The next thing is that the forces acting up should equal to the forces acting down, fulfilling Newton's state law of motion, which states that what? Action and reaction should be equal but opposite, meaning that that's why we say that R is equal to 0.45 newtons plus 0.90 newtons, which is equal to 1.35 newtons. To show you that, this one is to show you that all the forces acting up should be equal to all the forces acting down, so that these things should balance. Now, we move on now to calculate the moments. What is the moment? The moment about a point is the force times the perpendicular distance of that force from a point. Meaning that you cannot measure moments when you are not dealing with the force and a perpendicular distance. Had it been you are measuring force without a perpendicular distance, then it will not really go. But when you are measuring force against a perpendicular distance, then what you are trying to get is the moments. That's why the next question we'll be trying to answer to find out the moments about a point. Let's go to the question. Calculate the moment of the mass about the knife edge. 2 marks. Edge. This is the knife edge at C. The moment of the mass about the knife edge. We know that from here, right here, was 40 centimeters. Meaning that from this point, right here, should be what? 40 minus 15 centimeters. Which will give us 25 centimeters. Therefore, moment of mass will be equal to mass times perpendicular distance. Of mass. This one should be about C, isn't it? Because C is the knife edge. Now what you do is that you now say that you now have your mass, which is 0.45 newtons, times the perpendicular distance, which is, you change your distance to from centimeters to meters, which is 25 centimeters, which will be 0.45 newtons times 0.25 meters. From here, you have 0.1 125 newtons meter. Because when you multiply this by this, you have 0.1125 newton meter. That's the moment of the mass about C, or about the edge of the knife, because C is the edge of the knife.